Improve your network automation from one-off scripts only you can use to safe, robust automations you can share with your entire IT organization with Itential. Find out more at www.itential.com/packetpushers. That's www.itential.com/packetpushers. Today's episode of Heavy Networking is coming to you from AutoCon 1 in Amsterdam. I'm attending the event and recording with various folks about network automation. This is an excellent boutique event. Enough people here to keep it interesting, but not so many you feel overwhelmed by the crush of humanity. And there's going to be an AutoCon 2 event in Denver in late 2024, and you can find out all about it at networkautomation.forum. I am Ethan Banks, your host. You can connect with me on LinkedIn or on the Packet Pushers Slack group, which you can join for free at packetpushers.net/community. In today's network automation discussion, we're going to cover abstraction layers. Practically speaking, what are they and how do they help make your network automation project successful? We'll also discuss some of our guests' automation projects, how he used abstractions, and other lessons learned along the way. Jaakko Rautanen is our guest. Jaakko, welcome to Heavy Networking. And if you would you tell the folks who you are and what you do?
Thank you. Thanks for having me. So, first of all, I'm father of 6 kids.
Okay, nice.
They keep me busy outside business hours. So that's the first thing. Then I'm kind of a person who wants to understand how things work, always, in every area in my life. And if we think about professionally, I'm inspired by things like very clear illustrative network diagrams, things like streaming telemetry. I always get inspired when somebody helps me to understand how something works. If somebody can articulate very clearly some things or illustrate something, that's when I'm inspired. So, and also if I can feel from the other person's customers that they understood something based on the discussions we had or based on the solutions we provide, I'm inspired. So I guess that's who I am.
Yeah, that's okay. That was deeper than I was expecting. But it's funny you answer that way, in that I think a lot of us that are in network engineering identify with that. We want to know exactly how things work. We love our detailed diagrams that explain and illustrate the network from our perspective, how data is flowing through that infrastructure. That's how we think. It kind of makes up our DNA, who we are, so that you describe yourself that way. It's like, we're kindred spirits, man.
Yeah, that's true.
Now, as far as your day job, you consult, is that right?
Yeah, I have my own small business and trying to build a team where I want to work.
Okay. And what sort of businesses do you support? Enterprise, service provider?
Enterprises mostly, public sector customers. They have a sort of service provider type of networks, but not like the full service providers, right?
I follow you. Okay. And then network automation, how did you get into that?
Well, I think it was 4 or 3 years ago I got to this one customer to make network architecture work, and they were doing some network automation stuff, some early pilots, and then I got invited to the network automation team as well. So that's where it all started.
Okay. Now, when you and I were chatting on LinkedIn, you started talking about your network automation work, some of the projects you've done, and you mentioned the importance of abstraction layers right at the beginning and stressed that was something that a lot of people seem to miss in network automation. So let's dig into that. Define an abstraction layer to help people understand what we're talking about, first of all.
Yeah. I mean, even before that, let's try to really quickly paint a big picture first. So in my mind, the automation stack has 4 layers. This is my definition. You can have whatever you want to, but these are the main blocks in my mind. From bottom to up, we have the network devices, the running config, the live state of the network.
Yeah.
One layer up, we have the configuration pipelines, which are taking the data from the next layer, from the single source of truth database, and pushing that to the configuration to the network devices. You can do all sorts of CI/CD type of testing and validation in that layer as well. You can argue
before pushing into the
pushing.
Right.
Yeah, maybe you can argue if that's its own layer, but anyways. And then we have this single source of truth, which contains kind of the intended state of the network in detail. in some database.
Which I've heard described in a few different ways. One, some people would use GitHub as a repository that's got your intended state stored in files. Netbox commonly uses another source of truth that might have your intended state, what the network is meant to look like. You agree with that?
Yeah, there are like two types. It's a database or kind of a infrastructure as a code or kind of an infrastructure as a code approach.
Yeah.
In Git. But a couple of days ago, actually was it yesterday, I heard that Netbox is going to combine those two. So you are going to have the branches in Netbox, where you can spin up branch from the main branch and work on that in Netbox and merge it. I don't know the details. I'm really eager to hear in these days here because I know that Netbox Labs is.
There's a company called Opsmill that is announcing their open beta of the InfraHub project that I believe is got some of that kind of feature as well, where it is it's a source of truth, but it's also version control and combining a lot of that into one. So
yeah, because there are pros and cons on both of those things, and database solution is definitely missing the branching.
Okay. So that lays our groundwork then. Are you ready to talk about abstraction layers now?
Yeah. So I just introduced three layers in my stack. So
you did.
So the next layer, which is usually missing, or I don't know usually, but I have seen it missing, is abstraction layer, and that's maybe because it's so abstract. But let's try to define it first. So in general, abstraction is really abstract word. So what I mean by that, in this context, I mean mostly service modeling. Modeling the abstract network services so that users don't have to think about details daily basis. You make up the design, build in that into your abstractions, and then you can operate those abstractions, and the details happens under the hood.
So, for example, you could have, a BGP routing service, and on Cisco NXOS, it's defined one way, but on Arista EOS, it's defined a different way. So you could have a common data model that describes your BGP service, and then as an abstraction layer, you would configure at the higher layer what it is you want the BGP service to do and allow the abstraction to take care of the details of implementing it in the Arista box versus the Cisco NXOS box. Am I on the right track?
Yeah, okay. For sure. And then you can have a hierarchy of those abstractions. So you don't necessarily need to think about even BGP when you are deploying some higher level service, which is including BGP.
Okay. You're building, like I've heard this described as like a service catalog. You don't want to know the implementation details that BGP is a part of it. You just know, I want, a VPN service between two endpoints.
Let's take this practical. So let's go to the very practical examples. So let me give you a very simple example of abstraction first. So let's say you have MPLS network and backbone link. Mm-hmm. So if you go into very details, you have two devices which has configuration parameters, which has interfaces, IP address, which belongs to some prefix actually. Mm. So you have all of those details. But if you want to abstract that link, you need to take all those details and check each of them for which you have the logic, or you can implement the logic to allocate the details or reserve things. And then you do that. And then there are going to be some details which you could not come up with any, logic. And those are the ones which needs to be, exposed to the user. So in case of MPLS backbone link, which is really, really simple thing, you might end up having just a device, A interface, B device, and B interface. Mm-hmm. And that's it, what user needs to know. Prefixes are allocated under the hood. IP addresses are reserved under the hood. Maybe MACsec encryption keys are generated under the hood.
Yeah.
Maybe you get default IGP metric, which you can modify later if you want to. But that's kind of an example of simple abstraction.
All of that data would be queried by the process that's going to implement them from some resource pool, a source of truth perhaps, that's going to allocate all of those details that I don't want to have to care about. They're abstracted away from me. But I don't actually want to have to manage the MPLS level details and IP addresses and any of that stuff. I want the service just to handle that for me and me not worry about it.
Yeah, and it's important to understand that these details still matter, They have to be designed, and those prefixes still matter, so they are kind of predefined in the definition of abstraction or in the variables of, abstraction, one way or other. Mm-hmm. Mm-hmm. We can go to the more complex examples if we go through the real life cases or customer cases I have had.
Yeah, go for it. Let's get into some even more complex. Well, you said the MPLS one was simple, and I'm like, well, depending on who you are and what shop you're in, MPLS is more or less complex, all depending, because not everybody's running that these days.
Yeah, but the link.
Yeah, yes, fair enough. Yeah,
that's true. But the same logic goes when you build abstraction. The same method is going to be applied for any abstractions, Mm. Be it simple or complex. You need to apply the same method to try to get as much details offloaded from from the users as possible. Abstraction in general, it's all about hiding the details, actually. If you want to go to the example, so I have a couple of customer projects still ongoing, and we have been doing network automation. So the first one is media industry customer.
Okay.
Having a leaf-spine data center / campus style network.
Okay, so pretty traditional. Again, leaf spine probably, is it 3-stage?
2-stage, I think.
So just one access layer and one leaf layer and one spine layer.
Yeah.
Yeah, we're talking. Okay.
Yeah.
So small, not massive, but.
Yeah, I'm coming from Finland, so. Small in your terms.
Well, I wouldn't say that. Just because I'm from the U.S. doesn't mean they're all huge. I think if you're doing leaf spine, that's much more typical. Only when you're getting to very large number of server-facing ports do you get into the multi-tier.
This is growing all the time, and we need to think all the time the new topologies, and network design is changing all the time, which places its challenges for the automation because we need to keep up.
So media industry, leaf spine, okay.
Yeah, BGP, EVPN, VXLAN, stuff like that,
okay.
Providing layer 3 VPNs and layer 2 VPNs and stuff like that. Mm-hmm. The network is for delivering media streams between, studios and some delivery systems.
Multicast?
Multicast, lots of multicast.
Yep.
That much that you cannot rely on the traditional multicast delivery methods. You need to think about some SDN-based things to guarantee not to have any drops, for example. Mm-hmm. There is no role for quality of service whatsoever because you cannot accept any single drop.
So let's park on that for just a second. So no role for QoS because you can't tolerate any drop, as opposed to.
If you have a link with a certain capacity, 100 gig, for example, and you have, let's say, you have 9 streams which are all taking more than 10 gigs, and you got the 10th, so it's not allowed to break the 9.
Yeah,
9 other, So there are solutions for that.
So QoS doesn't help us here because we would be delaying packets for the feed, and this is one of those situations where if the packets arrive late, you've got a problem. They need to get there on time, or you might as well not bother.
Yeah.
Okay.
Maybe RSVP or something, but that's really old technology in my point of view.
Yeah.
Anyways, that's kind of a sidetrack.
Yeah.
From the automation, we don't have that much to do do with the SDN stuff.
So what automations are you building for this media leaf stream environment?
Well, this is fully automated, I would say. I need to get a little bit deeper.
Okay.
So if I go through what abstractions we have. So we have adding leaves, abstraction, leaves spine links, which includes, prefixes, PGP peers, things like that. That's kind of the underlay part. In the underlay, we have the physical connections to the firewalls and to some external parties. Mm-hmm. Then in the overlay part, we provide an abstraction for virtual network. That's kind of a term we invented in our network. What it means, it's basically a layer 3 VPN, VRF, but it has more. It has kind of attributes. For example, it has a Boolean attribute for firewall connectivity. So one checkbox, connect this L3 VPN to the firewall, which means if you select that one, the transit networks will be created, VLAN IDs will be reserved, IP addresses, PGP peers.
All the things that you would need to be able to get traffic in and out of that VRF via the firewall, because you're going to talk to some external, you're going to talk to something that's outside of that data center leaf spine environment.
Yeah, or maybe in other layer 3 VPN, the policy is to go through the firewall. So,
gotcha. Okay.
So that's kind of the thing. Then we have end-host subnets, which are, there are different types, but they might have one-to-one mapping one-to-one mapping is not necessarily right. End-host subnet can have one mapping to one virtual network, but virtual network could have multiple end-host subnets, obviously. An end-host subnet is another abstraction made by us, and that has its own attributes. Once we have those abstractions, it's really easy to add, virtual networks, VRFs, and and actually that's a really good example. If we create a virtual network in our network, the only mandatory parameters are, this is happening in Netbox, so tenant, which is specifying the network environment. Customer has multiple of those, and the name. Mm-hmm. You don't have to type in anything else. And when you add that, it produces like 500 lines of configuration for various devices.
So what process is actually creating 500 lines of configuration? Is it Python? What is it?
Let's walk it through. So we have these abstractions in Netbox. We decided to implement them inside the Netbox.
Okay.
So we made a plugin. So that's Python code.
Okay.
We have forms, same way as normal Netbox forms. We have list views, we have object views. Yeah. And when you create that kind of object, virtual network, what happens under the hood, it kind of populates the data in the Netbox, reserves those prefixes and, IP addresses, interfaces and things like that. And you can take a look at that in detail in Netbox through the normal native Netbox menus. Mm-hmm. Then when we have that data in kind of a modeled format in the database, then we have a code which converts that to the YAML format in the Netbox for each leaf, for example, for each device. And you can take a look. There is a tab in the device view. Right now in this project, we are using the config context view. Recently, Netbox announced this rendered config thing where you can implement that by Jinja templates inside the Netbox. But anyways, the end result is that we have full configuration of the each switch in the Netbox in some format which is suitable for that.
And at this point, it's sitting in Netbox. We haven't pushed it to the device yet. It's just sitting. It's been created. It's in Netbox, ready to be pushed in some way.
Yeah. So to push it, which has been activating the configuration pipelines, we have a button for that in Netbox.
Okay.
And depending on the vendor we are using, this network we are using Arista devices. So there is a really simple Ansible playbook taking the data from the Netbox and pushing it to the Arista Cloud Vision, which is the centralized management server of Arista. And actually, it's kind of offloads a lot of things from us, the Cloud Vision, because by default it has, this configuration management. It can show the difference between the live and candidate configuration for user. You can use it to push to the last push to the actual devices. It handles rollbacks. It does validations and stuff like that.
So does Ansible push to Cloud Vision and then Cloud Vision to the devices?
Yeah, and in that phase we have this human intervention to go to the Cloud Vision and press the push button.
Oh, okay. So Ansible will stage it in Cloud Vision, basically. And then you said there's a human at that point that looks at what's being proposed in Cloud Vision and says, okay, go.
Yeah, but that's a kind of a design choice. You can push using Ansible as well. You can kind of command the Cloud Vision to push it right away if you want to.
Mm-hmm. Or, you're an Arista shop using Cloud Vision, but you could be pushing from Ansible directly to the switches themselves.
That's right.
If you wanted. Cloud Vision doesn't have to be a part of it, it's just the way you chose to do
it. Yes, for sure. And then for Palo Alto firewalls, we have another type of pipeline. So we implemented the Python code inside the Netbox to consume the Panorama API and push the configurations there. But what we are doing with Arista is that we are replacing the full configuration of the switch each time by the configuration created by the Netbox.
So a full switch config gets pushed, not an incremental change, you're saying?
Yeah.
Why that? Is that important?
I think it is. We don't have to think about that much about removals, for example. If something gets removed in the Netbox, the new configuration will be generated in the Netbox. It gets pushed to the Cloud Vision, and Cloud Vision shows the difference. We don't have to say to Cloud Vision to remove something,
So you leave it, okay, the distinction here is you're actually leaving it up to Cloud Vision to look at the existing state of the device versus the intended state, find the diff, and then Cloud Vision will push. Cloud Vision is not going to push a whole config.
I don't know how it works, inside, but that's what we do.
Yeah, but you leave it up to Cloud Vision to make sure that device configuration ends up where you want it to be, however Cloud Vision does it.
Yeah, I think it does not push anything which is already there because, it doesn't even give you an opportunity to push to the devices which hasn't changed, for example.
Yeah, okay. And that makes sense. It would only be pushing a diff. So, okay. And so then in Cloud Vision, you end up with, I don't use Cloud Vision. I'm not familiar with it. Do you get a record of changes that have been made on this device over time so you can look at history and these kind of things? Or what else
Cloud Vision is really good on streaming telemetry, and you can see everything in history and in live. And you can see all the changes. You can take a look to the configuration of the device live, which means, second after you do some manual change, you can see it in Cloud Vision. You have a slider to go back in time and see how has it changed. You can compare timestamps and stuff like that. It's really rich in terms of streaming telemetry.
Okay.
Not only not only the configuration, all sorts of stuff.
Yeah. So are you you said Palo, but as far as the switching and routing infrastructure, is it all Arista?
In this customer, yes.
Yes.
Well, there is some side networks which are going to be removed, so we haven't automated them. Might be some other vendors there, but
A quick sponsor break courtesy of Itential. Itential is the network automation platform you get to build robust, self-service automation that is safe for your entire IT organization. Now, if you've been writing your own automation, I'm guessing you've run into this problem. You have a directory. It's got a bunch of Python scripts or Ansible playbooks in it, and yeah, they're way better than CLI copy-paste, but who besides you can safely use those scripts or run those playbooks? It's all a bit fragile, and that makes you irreplaceable, and that's not good. You want to be able to go on vacation or be sick or have dinner without getting a call, which means you need a network automation system that is not fragile, that anyone in your organization can use, and that leverages the automation work you've already done. And Itential gives you all of this. With Itential, you'll be able to run your scripts safely as a workflow that integrates with your change management, your IPAM, monitoring, your ticketing system, and anything else that you need. True network automation. Not something that just saves you some CLI time, but something that touches everything that needs updating and testing when you make a network change. And Itential is low code. You don't have to be a software developer to use it. Whether you're just getting started with network automation or you're deep down the rabbit hole with GitOps and pipelines, Itential can help. Automate from ticket creation to ticket closure with Itential. Find out more at www.itential.com/packetpushers. That's www.itential.com/packetpushers. So you've described the ability to automate the underlay where you add new leaves to the leaf spine infrastructure.
Yeah.
And I'm just curious, is that something you do a lot where you're adding new switches as leaves? Okay.
No, that often. Not that often, but it still makes sense because it's easy to automate, actually.
Yeah.
And
there's a lot of details to get wrong in that when you get into VXLAN, EVPN, and security controls and then pushing routes around. There's a lot of, if you're building that as a human by hand, there's a lot of opportunity to make mistakes. If you automate it, I would assume your mistake count goes way down.
Yeah, there is lots of things. There is a link. There is a prefix, there are IP addresses, then there are actually two BGP peers in our case. One is link peer and one is between the loopbacks and, stuff like that. So, but yeah, there was one detail I want to highlight. So when I said everything is automated, it doesn't mean everything is abstracted. So we have also the static configuration templates, or actually they are called as config contexts in Netbox. We utilize that feature to inherit the common static type of configuration to each device in Netbox. So when the configuration leaves Netbox and it's going to the devices, it's full. But it doesn't mean everything is abstracted, because it doesn't make sense to abstract things which doesn't change ever.
Such as, give me an example of that. I'm having a hard time picturing this.
Well, it depends on your environment, but for example, if there is NTP servers,
okay,
they might change, but they
pretty rarely.
But it doesn't. If there is a one YAML file, config context in Netbox, where you can go and edit those details. That's maybe enough. You don't have to implement the feature for NTP server. But if that's your business to change NTP servers every day, maybe you want to do that.
I gotcha. Okay.
It's depending on a business.
So you didn't do a lot of abstractions there because it's not the kind of thing that changes a lot. It's enough to be able to just pop into the YAML file, make a change, and off you go, rather than have some kind of an external data model that it takes you a step away from what's going on. You don't really need that in those cases.
But then if you think about layer 3 VPN, there are lots of stuff. So even, they happen more often to add or delete layer 3 VPNs or virtual networks, as we call them. But even if it happens really rarely, it's a really complex job. So it might be worth of it to abstract it anyways. Because, if you do that, every half a year, you don't remember what you need to do. So it's not only the most common tasks or most repetitive tasks, it's also the most complex ones, I guess.
It's funny what you say about the every 6 months thing. So that's the classic network engineer problem, or anybody that writes code of any kind.
Yeah.
You don't touch the code for a long time. It's like, I hope I commented this. I have no idea how this works anymore unless I commented it.
Yeah, and especially if you work for multiple customers. So
yeah. Okay, so media industry leaf spine network. That we think we covered that pretty well.
Well, I would like maybe highlight the future of the network, because
yeah. I actually have a question sitting right on my script, and I meant to ask you that. What? Because you had told me there's more stuff you want to automate in this environment.
Yeah, definitely. So there is this one guy in this customer who is really visionary thinker. He pushes us all the time. Normal engineers like me, we need to really try to keep up what he is trying to do. But the good thing is that, or what he is trying to say, and where we are going to. But he's pushing us, for example, right now, to abstract firewall rule bases.
Okay.
And first of all, it might first sound like really easy job, but for me it doesn't make sense to move the firewall rule base from the, let's say, panorama to netbox as such. No abstraction. So that doesn't make sense. So now we are thinking things like, we have all the end hosts in the netbox, all their IP addresses. What if we have a model for endpoint groups with dynamic selection criteria, so that when new end host is going to be added to the netbox, which matches the selection criteria of a endpoint group A, it will be included. That's kind of a first building block for firewall rules.
Yeah. So the point of this, because at first you said, okay, what if we put the rule base in Netbox, as an abstraction? What if and my brain was going, but if everything lives in Palo, why? What's the advantage here? It's not multi-vendor. It's not. But I think I get where you're going. If you do that, then you can not only instantiate the object with all of its routing parameters and all the things that it needs, but also its firewall parameters. It becomes another characteristic of that endpoint object, all living in Netbox. You get a more complete picture of how that device relates to every other device on the network in this way.
Right. And then we can have a high-level rule base, which has not that many details as normal low-level rule bases, as I call them now. So we have a source endpoint group, destination endpoint group, and application. That's it. We have multiple firewalls. They form some sort of topology. That's hidden. Yeah. User don't need to think about that. And when you're creating one high-level rule, it might end up to be multiple low-level rules in different firewalls. Yeah. Also, we are doing only really strict openings, and by really strict I mean only host IP addresses in the rules. So we are increasing the security level, or that's what we are planning to do. This is not in production yet. So when you do firewall rule base, if you do that manually, we are opening really wide. Actually, we are using zone-based rules or subnet-based rules, and we are accidentally opening opening connections to and from, for example, gateway addresses, which are not intended to.
You wouldn't need those two endpoints to talk to each other, but they happen to be included in a subnet, let's say. Yeah. And so you end up with that opening, even though you don't want it to be there. So you're heading towards more of a microsegmentation approach.
Yeah, maybe. And that information could be used in access list as well. So we haven't finalized yet. We don't know where this is going.
But within Netbox, if you do it this way, it gets easier to build a policy like that, to create a policy like that, because you have endpoint-oriented information. With automation, it becomes easier to build what that very granular, very detailed policy would look like, whereas it's too difficult to manage. It sounds like you're doing it more or less by hand in Palo now, the way you're describing the rule sets.
Yeah, more or less, yes.
Yeah. Well, they're not entirely by hand. You have automated some of those groupings between VRFs and so on, you said.
Well, it's only the network configuration of Palo Alto interfaces, PGP peers at the moment.
Okay, not security policies.
Not security policies.
Okay, I got it.
Yeah.
So that's a future thing you would like to do.
That's a future thing, and it's pushing my mind in the limits, but Let's see what is going. And that's not only the technical question. That's also the, way of working question. And it's really big mind change for people. And there, as in any automation, you need to put in effort in advance to get some gain. So that's the same here. You need to discover what each device is doing. What protocols it's running, or is it server for some protocols or client for another, and things like that. And that information needs to be stored. So that's something we are thinking about.
Okay. All right. Now there's another network you would want to talk about. The transport industry MPLS backbone. You've done some automation work for.
Yeah, that's my another customer, and they are providing services for road traffic management systems. So this is a kind of a special purpose network, and it's MPLS type network, and multicast as well for cameras and.
Yeah, I was like. Transport? Why? Oh, okay, it makes sense. Transport.
Well, there are cameras in tunnels and in roads and stuff like that, and all sorts of traffic management systems, signs and speed limits and whatever info screens and things like that.
So that. I guess this is it. What automations have you built for this environment? We get the idea of it.
Yeah. So the stack is really similar compared to the first one. We have Netbox, we have abstractions, then we have config pipelines and the devices.
Okay.
But in this case, we are using Cisco iOS XR devices, and the customer didn't want to pay for NSO. So we needed to invent some functionality of pushing the configuration.
It was cheaper to pay Jaakko than to buy NSO? It's Network Service Orchestrator by Cisco. It's an automation platform, if you're listening to this and unfamiliar. Yeah.
We'll see if it is. But, that's the direction we took, or they took. And now we are implementing our own pipelines, and we need to develop those validations and rollbacks and stuff like that. And I have to say it's a heavy work. To get it right.
Not that NSO would have been, free. It's a platform. You still got to build, lots of things, with that tool if you're going to use it as a platform. It's just, curious to where the pricing came out, that they brought you in to build something more or less bespoke.
Yeah.
As opposed to laying into Cisco's NSO, because it would do well with XR, iOS XR, and its data models. NSO, it would do well anyway. Then they didn't go that way there, because they want Jaakko. Yeah. So you're building a similar stack, similar kinds of automations.
Yeah, we have for abstractions we have adding the MPLS routers. We have only PE routers, so adding PE router, adding MPLS backbone link. Then we have layer 3 VPNs, pseudowires. Firewall connectivity. We are going to have the data center connectivity from the MPLS networks and such.
So give me an example of some kind of a network change that would require you to call upon the automation platform to deliver that change.
Well, whenever we need a new virtual network, layer 3 VPN.
Sure.
Same thing. Just go to Netbox, add new one, minimal parameters, and then push. And here as well, we replace the entire configuration of the router, completely by Netbox, but by Netbox generated one.
And so then from Netbox, in this case, before you were using Ansible to push to CloudVision, and then CloudVision would figure out what the diff was and then send that down to the devices. Here you've got Netbox building a whole new configuration, and then what happens?
Well, we have had a couple of generations of this configuration pipeline, but what we are now doing is that we are developing that inside the Netbox. So we show the diff inside the Netbox.
Okay.
And we have the push button inside the Netbox. So that's Python code, and
And when you click push, are you using Ansible to deliver to XR?
No. We are actually using netconf.
Okay.
So it's the Python NC client
library. Yeah, you're using Cisco's Python library for to push. Yeah.
Yeah, and because we are using netconf, I don't know if that was the right choice, but that was the choice we made. We need to produce the configuration of the devices in Netbox as in Young format. Mm-hmm. But because we don't want to use XML, because that's awful, there are so many unnecessary characters, really hard to read. There is a format.
I could argue Yang's not a lot better, but but anyway, okay.
But you can represent Young in JSON as well.
Yes.
So we do that, and there is a translation to the XML, so that you should. Okay. So that's a little bit. I don't know if that's optimal, but that's what we are doing right now, and it works.
Yeah. Okay. So you've got the config. The config needs to be expressed as a Yang model, which is something XR understands. There's a whole bunch of Yang models that are built into XR.
Yeah, you need to select the right ones. Well, what do you want to use? For us, they said just use unified models. There are Cisco native models, which are the old ones, and then there are these models, what they call unified models. So we went with the unified models.
That all is expressed as JSON. You're feeding JSON to the Python script that then delivers that payload over netconf to the device.
Yeah, as XML.
Yeah, as XML, right? There's a translation XML.
But the good feature is that when you log into the XR box, you can say so running config pipe JSON unified model, and or so running config interface blah 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 pipe JSON unified model, and you get the exact JSON formatted Young format, whatever Young model, which you need to take back to your templates.
Okay. Do you have, one thing we didn't talk about in this was, do you have a pipeline where you can test check anything before you actually deliver?
We don't have much that. So the first customer, it has been production for 2.5 years or something like that. And it has been going really well. The Cloud Vision does lots of validation for us. We have been thinking about some digital twin type of network as part of the CI pipeline to verify things, and that would be really, really useful for multiple purposes, for the CI obviously, but as well as when the network design changes and you want to make the automation to support it. It's really, you just need to have some sandbox to play in.
Yeah.
So I'm looking really forward Container Labs. I met this Roman Dodin here in Amsterdam, and we had a
Roman Dodin of Nokia, and he's very vocal on LinkedIn. He blogs a lot, shares with the community massively, and Wright is certainly a big leader with Container Lab and that platform for labbing.
They are doing really interesting things. Roman is definitely a giver type of person, and that's actually really, really good. Yeah, I've been playing with that for a while, but not any concrete plans right now.
Yeah, and I know Arista plays well with Container Lab. They've got the CEOS version of their operating system, so that would work very well.
Cisco iOS XR as well. So they have XRD, and that was actually a really good experience. When I first learned about Container Lab, I tried XRD, and 10 seconds it was running on my laptop.
Okay, that's what I was going to ask you, because I haven't messed with XR in a lab environment for a couple of years, and the only image they had the last time I looked was XRV 9000, which is a beast. It needs 16 gig of RAM, and it takes forever to boot. So it sounds like they've changed that.
But this Container Lab, running network operating systems as a container, that's just something world needs. It's so fast. It's so fast.
So you think you could build a viable digital twin, so to speak, a lab version of the things you'd need to test
Yeah.
You include that as part of your pipeline, build some testing in to make sure of, whatever the tests are you want to run, you've got the right number of routes in the routing table, whatever it is that you're looking for, and then get back a result set and go yes or no, and then go from there.
There are these pretty obvious tests you want to make in this type of underlay-overlay networks. For example, you want to have full connectivity between the loopbacks of the network devices in global routing table. That's kind of a no-brainer. Mm-hmm. If you break that, you should not push.
Right. Right. My BGP adjacencies are down. What's happening? Yeah. Okay, so you've built some automations for this transport industry MPLS backbone, building out VPNs, kind of standard stuff. Are there other automations that you're doing today?
No, not yet.
So
this is still in progress. We went into production like 1 month ago or something like that.
Okay.
But there are network switchovers going on and things like that which keep us busy. So and this is more like a project. However, I think the network automation should be taught as a process or development, process, continuous thing.
So then what's next? If you've got a process here for this transport network, do you have future plans, things you want to do?
Sorry, what do you mean by that?
New automations that you want to do for this network?
Well, the customer has a list of needs, which is really long. They want to have all sorts of integrations to different systems, to the AD, to their CMDB, to some other systems, and let's see when we have time for that.
All right. Well, so we've talked about a couple of networks. We've been going for almost 45 minutes here. I did not expect this to go so long. This is great. I'm picking your brain and getting a lot of good stuff here. As you look back on some of these projects and maybe some of the other automation work you've done, what are the big technical lessons you've learned that you'd like to pass on to people?
Yeah, I guess the question is that what of those decisions we have made is still valid, and if I get the chance to do the next one, what of those decisions I will bring with me. So I think the replacing the full configuration of the devices is definitely the one technical lesson.
Again, that's happening in Netbox as far as that goes. The way the change might actually be pushed to the device might be a diff, but you're talking about the generation of the configuration at a higher level.
Well, yeah, we generate the full configuration, and then push the full configuration. Whatever is the details in that push operation, if there is some system in between, I guess actually NSO would do the same, that you can push the full configuration to the NSO and it figures out the differences and does only what's needed. If you have that layer. Yeah, that's the thing. We don't want to deal with the add, remove and like single operations. And by the way, one of the things is that these changes need to be atomic, both in database level as well as in the push phase. So in Netbox, if you add virtual network kind of an abstraction, there are lots of things the code does. But if any of those fails, nothing should be written in the database.
Right.
We cannot tolerate some inconsistent state of the database.
Yeah, you don't want half the change written and then it failed and now you've got this odd state where half the change is now written in the database. It doesn't reflect what's actually going on and so on. So it's got to be all or nothing. So
that's our main requirement for any abstraction. So it has to be atomic, and that's what it is in our network. And then the pushing should be atomic as well. And there are different flavors. Cisco in Cisco EOS XR, they call that pseudo-atomic process, which I have been experiencing myself. When I push the chains, things start to happen, which are supposed to happen, BGP peers overlapping. And then comes error, and everything's rolled back. But you already have an impact.
Yes.
So that's not full atomic at the moment. I know that Cisco is releasing full atomic change for XE devices. So I'm waiting for same for XR, because
You think they would have led with XR? That's interesting. But, I mean...
Yeah, maybe there are some historical reasons or something like that, but it's kind of atomic that the end result is the same, but you caused an impact with the incorrect change. So, yeah, that's one thing. Try to reach atomic things.
Other big technical lessons you want to share?
Technical.
Well, as opposed to non-technical, because with non-technical, we can talk about, the impact of working with humans and the people impact and that kind of thing.
I think we covered the technical part.
Okay. So then that's my next question. Everyone that moves to automation within their networking environments talks about the challenge it is, the mind shift to go from the way you used to do it, typing on a keyboard one device at a time, to network automation as a system and a platform where you're delivering changes via a system like you've been describing today. Was that a big challenge for you? Are there other observations like that you want to make?
Well, it's a bumpy road. You should accept that first. That's the first thing. I made mistakes. I was really eager to go with the automation, and some other people as well. Some other people not so much. And I was part of the network team as well as the automation team, kind of two roles. So for a while I forgot those network guys, and I just specified things as I am network engineer in the network team. But those guys who were doing kind of a daily changes, they were not involved in the first phase really well. I don't know if they wanted to, but at some point, I realized that was a mistake because they didn't buy the thing. But nowadays, it has getting better. They have been involved in the team. They are participating in the development process. They are part of the designing the abstractions. Then we deliver it. They test it. They know what's coming, and that's so easy for them right now. So that's definitely a kind of a lesson I have learned.
What about leadership within the organization, management level, and this kind of thing? What impact do those folks have on a network automation project? Well,
leading a change like network automation is leading like any change, I guess. It definitely helps if you have built trust, if you have trust in your team, if you have built and maintained the trust. If people feel heard, seen, and understood, it's really, really much easier to do or carry on some big change, obviously. So you need to implement those basic leadership practices. One other thing is that I'm actually really interested in leadership for some reason, have been for a couple of years now. So there's this guy called who is Simon Sinek. I don't know if you know about him.
Yeah, I know, I've heard of Simon, yeah.
He's a speaker, really inspiring leadership speaker.
Yeah.
And he talks about this concept called the law of diffusion of innovation.
Okay.
He puts it really well. Just go online and see his explanation on that if you haven't. So, but really quickly what it means, this actually comes from the marketing. So if you want to have an impact for some people, then the people are falling into the whole population you are trying to impact is falling in the bell curve that has been studied. And first 2.5% in the bell curve, they are kind of innovators statistically. And, next 12 or something percent are early adopters. Then there are first majority, which is 34%, and the late majority, 34%, and then there are laggers who will never buy your ideas. But the problem people usually make when they are trying to get the new idea through, they are targeting their message to the majority, 70% of the people. Kind of makes sense, but it doesn't work. That's because these people are different types of people. the early adopters, they are really risk tolerant. They accept the high price, you know. They accept the bugs. They want to work with you. They want this change. Whereas the majority, they are much more rational. What will I get from this, you know? Convince me this network automation will work. Mm-hmm. Tell me the date. It's in production. Things like that.
Right.
By listening to those comments, you can tell that that's the majority people, maybe lagger even.
Yeah.
Anyways, those people, they're not bad people, but they don't start to use anything which somebody else hasn't used before.
Yeah, they want the risk taken out of it because someone else has taken those risks and figured it out. Yeah.
Yeah. And, you know, there is this, in this law, there is this 1 point, 15 to 18% of the people. If you get that much on your side, it's the tipping point. It will just go on its own. The secret is work on those people, early adopters and innovators who want to work with you. They alone make that around 15%. It's really, really fun also work with the people who want to work with you. So that applies to any part of the life, but especially.
So with network automation, then you're saying, in your experience, you don't necessarily have to have everybody on your side, if you will. You can kick off a project as long as you've got a few key players that are on board and want to make this happen, and then everyone else will follow over time. Yeah,
and you know, start to work on with some eager people and do demos, and maybe you can take one part of the network and automate that. And when people see what you are doing, then they, that's what you mean. This is actually cool. If you just try to explain in theory something, people are, They don't get it. So kind of accept that people go through the change different times. In network automation, there will be obviously a point where you need to roll out that to get the advantage.
You need everybody on board at some point. Everyone's got to commit if they want to or not. For it to work right, you need everybody to engage and be using that system. Yeah. Well, Jaakko Rautanen, this has been a great conversation. If people want to follow you on the internet, maybe they got questions for you, how can they follow you?
Pretty much the only thing I have in internet is LinkedIn and my company webpage, which is still in Finnish, unfortunately.
Okay.
But yeah, connect me on LinkedIn, email me, call me, let's have a discussion.
Okay, so you heard that, LinkedIn, Jaakko Rautanen, and we'll have a link to that in the show notes at packetpushers.net. And thank you for listening to Heavy Networking today. Don't forget to check out networkautomation.forum to learn more about the live in-person AutoCon events where I met Jaakko and many other network automation enthusiasts. I've been your host, Ethan Banks. You can connect with me on LinkedIn as well, and you can chat with me on the Packet Pushers Slack channel, which you can join at packetpushers.net/community. And while you're there, avail yourself of the many other free and ungated Packet Pushers resources designed to make you even more awesome at your job as an IT professional. We've got podcasts that teach and keep you up to date, newsletters surfacing stuff we think you should know, YouTube videos to train and demonstrate, and more, and it's all free for you. If you want to tell us what you thought of this episode or anything on your mind, you can check out packetpushers.net/follow-up. We read every message that comes through and respond when we can. And to my vendor friends, you can be part of the Packet Pushers conversation like hundreds of other vendors have been over the years. Sponsor an episode and let's get nerdy talking about your product or service, or have a discussion about what's coming next in networking, cloud, or security. Lots of options to fit every budget, and we make it super easy to take part. packetpushers.net/sponsors and fill out the short form on the page. We will be in touch. Last but not least, remember that too much networking would never be enough.